मैन्युअली रेकॉर्डिंग करना पड़ता है साहब।
Yeah, very good evening. I am very fine.
Okay, ma'am. Now, ma'am, please allow me to have the short introduction of yours, and then we would be starting this session.
Yeah, fine.
Good evening, students. Here we have an excellent opportunity today to learn the deep learning concepts for computer vision. Our session expert is Dr. Mayuri Mehta, professor at Computer Engineering Department, Sarvajanik College of Engineering Technology, Surat. She is a passionate learner, teacher, and a researcher. She received her PhD in computer engineering from SVNIT, Surat. Her areas of interest include data science, machine learning, deep learning, health informatics, computer algorithms, distributed computing, and Python programming. She has total of 23 years of professional experience, which includes many academics and research achievements. She had a total of 17 patents and co-edited 4 books. She has published 37 plus research papers and 3 book chapters. She has worked on several academic assignments in collaboration with different professors of universities across the globe. She has visited 10 plus countries for the same. She has served in several international conferences and conducted 90 plus sessions in international conferences, short-term training programs, and faculty development programs. Madam has performed many projects on deep learning, many real-life projects on deep learning. So she has vast knowledge and exposure on the same domain. She is a member of Board of Studies, Research Progress Evaluation Panel, and thesis examiners of many universities. So friends, we have these opportunities to get the knowledge and exposure of deep learning, the most advanced technology of machine learning. So now I'd like to hand over the session to Mayuri Madam. Ma'am, please, you can start the session now.
Yeah, thank you. Thank you so much, Professor Gopi, for a very nice and overwhelming introduction. Thank you so much. I can see that huge participation is there in the subject, and I am pleased to notice that approximately 280 students, they have opted for this subject. Like it's good to notice this huge number. Okay. So dear students, like anytime during the class, feel free to ask me any question. You can also write your question and raise your hand, right? We will have like this is today I am starting, but today I'll not give you heavy dose. Gradually, we will move towards the deep learning. Because as you know, deep learning, this is specifically for computer vision. You will learn deep learning for computer vision because mainly deep learning is used either natural language processing or for computer vision. So the main focus of this subject would be on how deep learning is useful for computer vision. Okay. So let me start. Okay. The contents in my slides, they are either compilation of the information from various resources or they are from my own research work. And this contents in slides, they are for information and education purposes only. These are the learning outcomes of this subject, not this session, but this subject learning outcomes. So at the end of this subject or this semester, you will be familiar with artificial neural network and deep neural network. You will also be familiar with differences between artificial neural network and deep neural network. Then you will get knowledge on convolutional neural networks, its classification and how convolutional neural network is used for classification and object recognition problems. You will also be familiar with architecture of convolutional neural network. You will get insights on transfer learning for image and video processing because this convolutional neural network, it is mainly used for images and video processing, image processing and video processing. So you will get insights on transfer learning for image and video processing, and you will also get exposure to a few convolutional neural network based real-time applications. So this will be your learning at the end of the semester, at the end of completion of this subject. Fine. I hope it is fine if I turn off my camera for better connectivity, because I'm using my mobile data pack. And I think I should turn off video for better connectivity so that you can
Yes,
also focus
sure,
more on
ma'am.
slides. Okay. Prerequisites for this subject is machine learning. So I assume that all students, they have fundamental knowledge on machine learning. So I will start, though I'll briefly introduce machine learning, but it would be a very brief introduction to machine learning. But I assume that you are familiar with, you have learned machine learning so that you can quickly understand the concepts of deep learning. Okay. Okay, so let us start. Okay, I have not shown you the syllabus. Okay, later I'll share with you, or Professor Gopi might have shared with you the syllabus of this subject. And as you know, the first module of this subject is related to artificial neural network. So first we will discuss artificial neural network, then gradually we will move towards deep neural network and differences between artificial neural network and deep neural network. But as I told you, today I won't give you heavy dose. I will simply introduce this major terms related to this subject, and as per unit or as per syllabus, we will start from next class. Okay, so these are the buzzwords. Today, everyone knows, like artificial, even the common man, they know what artificial intelligence, machine learning, deep learning, data science, Internet of Things, cloud computing, blockchain, right? People, these are the thrust areas today in computer science. And almost every student knows these buzzwords, but less people know that how these fields are interconnected to each other and what is the relation between them. So if you see, many of these fields are interconnected with each other when you apply to real life applications. And when we will discuss applications, you will also understand that how these fields are interconnected with each other. And today, be it computer science, be it IT, be it chemical engineering, be it mechanical engineering, any discipline, the subjects, artificial intelligence, machine learning, deep learning, data science, they are useful almost to every discipline. So it's not necessary that you should be engineer to learn these subjects: AI, machine learning, deep learning, data science, right? Any like this subjects introduced almost in every university, in every major branch, and these are learned by other discipline students also, because they are applicable to almost every real life sector. Fine. So let us first discuss the evolution of deep learning, because you are going to learn deep learning for computer vision. So let me briefly tell you the evolution of deep learning. So here in this first diagram, you can see that outer circle represents the artificial intelligence. Artificial intelligence, if I briefly define how, I don't know how many of you know exactly what the artificial intelligence is, right? But you might be knowing, and you might be knowing the different definitions also. But if I briefly tell you what is artificial intelligence, then it can be defined as a branch of computer science which has potential to analyze complex data. It is a branch of computer science which has potential to analyze complex data. Sometimes this is called machine intelligence because it is an intelligence demonstrated by machines in natural intelligence demonstrated by human. So that's why it is called, this is machine intelligence, right? And machines are made to learn from data, and that is called artificial intelligence. Artificial techniques have potential to learn from complex data. And everyone knows that today we are generating tons of data every day through social media, through e-commerce website, through our mobile phones, right? We are generating tons of structured and unstructured data. Now, when we are generating this tons of structured and unstructured data daily, we need techniques to analyze this complex data. And until and unless we derive knowledge, we make sense of this data is not useful. So for this data, we are using the artificial techniques to analyze this complex data. The various subdomains of artificial intelligence, as you can see here, They include reasoning, knowledge representation, like you can see neural networks, evolutionary computing, machine learning, natural language processing, expert systems. So these are the broad subdomains of artificial intelligence. And among these several subdomains, machine learning is one of the popular and it is widely used subdomain, this machine learning. So you can see that machine learning is one of the subfields of artificial intelligence. Among the several subfields, machine learning is one of the subfields of artificial intelligence. This machine learning, if we define briefly, though you have already learned this subject, I assume, machine learning is a subset of artificial intelligence that includes statistical techniques. Now, this statistical technique means to improve a task with experience. This term machine learning, actually, it was coined by Arthur Somel in 1959. So this machine learning and artificial intelligence, these are not new domains. Okay, these are there since many years. So in 1950, almost in 1950, artificial intelligence was introduced, and in 1959, machine learning was introduced, and that year was probably the most significant in terms of technological advancement. Yeah, someone has raised hand. If you have any query, you may ask me. Anush, you want to ask something? Okay, if no question, then we can proceed. Okay, so machine learning is one of the subfields of artificial intelligence, and this machine learning is used anywhere for automation, be it healthcare domain, be it finance, be it education, right? Any domain, this machine learning is used for automation. So you may already be using a device that utilizes machine learning. For example, you may be using a wearable fitness tracker like Fitbit or some other device, and this is machine learning based application or device. You may be using intelligent home assistants like Google Home, Alexa, and these are also machine learning based devices. And there are many more such examples which we use in our daily life. If I give you like some more examples, then search engine result refining. We use search engines almost daily. So this search engine result refining, it is based on machine learning. Google and other search engines, they use machine learning to improve search results for you. Every time, how they use machine learning, let me explain you. Every time you execute a search query, the algorithms at the back end, it keeps a watch at how you respond to the results. Because once you type a query in your search engine, in response to that query, you will get results. So algorithm at the back end, it keeps watch on how you respond to results. If you open the top results and stay on the web page for long, the search engine assumes that that result is in accordance to your query. The result it has displayed, which you have opened, it is in accordance to your query. Similarly, if you reach the second or third page of the search result, but if you do not open those results, the search engine assumes that those results are not as per your requirement. They did not match your requirement. So this way, the algorithms working at the back end, it improves the search results. So this is also like application where we use machine learning. So as I told you, there are several day-to-day life examples where we are using machine learning now. So this is about machine learning. Okay. Now, what is deep learning? Deep learning, it is a subset of machine learning. It comprises of algorithms that permit software to train itself to perform tasks like speech and image recognition by exposing multi-layered neural networks to vast amount of data. These two words are very important: multi-layered neural network and vast amount of data. Because deep learning neural networks, they are deep in architecture, and that's why they are called deep neural networks. And they are also called multi-layered neural networks or multi-layered neural networks. And this deep neural networks, they are exposed to a vast amount of data so that machine can learn in deep. I'll explain you this later when we will discuss deep neural network, but this is how like our deep neural network differs from normal neural network. Fine. So this is like deep neural network. Fine. Okay. Now, before Let me tell you in brief that what is neural network, artificial neural network. Though I will discuss this artificial neural network in deep in next class, I'll tell you brief. I'll tell you in artificial network. Why is it required? For what is it? To artificial biological neural. They have standard capability. They also have capability to work in parallel, and all these neurons are connected with each other via massive parallel network. So this is our biological neural network. Now this artificial neural network is derived from biological neural network that develop the structure of human brain. Now similar to our human brain, that has numerous interconnected that has neurons interconnected to each one with neurons which are interconnected to each other. This artificial neural network also have neurons that are interconnected to one another in various layers of the network, and these neurons are known as nodes in artificial neural network. So as you can see in this figure, like you can see that on the left hand side there is a part of our biological neural network, and you can see that dendrite, cell nucleus, axon, synapse. These are the different parts of our biological neural network. And similar to this, here on the right hand side, you can see that there is a figure of artificial neural network. And you can see that in this artificial neural network, like here is the input layer. These are the inputs. These are called nodes. Okay, this is output node. This is neuron. This is very basic structure of neural network. And see the similarities between these two networks. You can see that biological neural network, they have dendrites. So they are inputs in this. Dendrites means they are input to neuron. Here, this is like neuron. Okay, so dendrites, and here we have inputs. Here we have cell nucleus, and here we have node. So you can see that this is node and this is cell nucleus. This is synapse. This is our synapse, okay? And here are the weights. And this is axon, and for axon, we have output node in artificial neural network. Okay, now let me tell you how we use biological neural network and for what we use our biological neural network. It is used for learning. We learn everything through our biological neural network. I give you a very simple example. When we were kids, we learned talking and speaking through analysis and observation. We observe and analyze walking and talking style. When we were kids, we analyze walking and talking style of the people around us. We learn speaking, we learn talking, we learn walking, right? As we grow, we go out. As we go out, we meet more people. We hear more people. We learn from there, and our vocabulary increases, and our speaking also, like our speaking accuracy also increases. So this is how we learn, and we learn through observation and analysis, right? Uh, as this neurons, the neurons learn through observation and analysis. As we learn through observation and analysis, as our learning increases, our accuracy in that task increases because our learning increases. And that's why we say that जैसे जैसे बड़े होते जाते हैं, हमारे experiences बढ़ते जाते हैं, and we learn more things. Because when we learn more, our accuracy increases. Neurons in our biological neural network, they have capability to work in parallel. I give you example for this. We can, when we drive car, we control accelerator through legs, right? We control gear through hand, and we take judgment through our eyesight. So all these three activities we do in parallel. Why we are able to do in parallel? Because neurons in our biological neural network, they are connected with each other. They have ability to work in parallel, and we are doing three things together. We take judgment through our eyesight. We control gear using our hand, and we control accelerator through our legs. So we do all these activities together because neurons can work together. They can work parallelly. So this is how our biological neural network works. And based on this concept, the artificial neural networks have been derived. Artificial neural network also has millions of neurons connected with each other. They have send and receive capability, and they do many things at a time. So this is how they work. Okay. These are the samples of several neural networks. There are several neural networks available in literature. You will find many more architectures if you search in literature. So here are some sample neural networks. The basic unit of any neural network is neuron. Basic unit, I give you, like I am expanding this. Okay, I am expanding this simple neural network, which is known as perceptron. So if you see in this neural network, like the basic unit for any neural network is neuron. Neuron takes inputs as neuron in our biological neural network does. It takes input. It does some processing and it produces output. This is what is done by neuron in our biological neural network and neuron in artificial neural network. It takes some input, it does some processing. In case of artificial neural network, it does some mathematics. It does some mathematics with input and it produces output. So these are the two inputs, X1 and X2, and Y is output here. And this is like blue color circle. It represents the neuron, and neuron does some mathematics with input. So this is how, like this is two input neuron. This is how two input neural network looks like. Now, three things are happening here in this simple case. Three things are happening. First, each input, like each input X1 and X2, it is multiplied by some weight value. So here on this bar, we have some weight value. Why weights are required, I'll tell you later when I'll start like next class. This is like fundamental I am discussing related to artificial neural network and deep neural network. Okay, so these are the two inputs. They are multiplied by weight values, and all the weighted inputs, like suppose, for example, here, suppose, let us assume that the weight value here is W1, in weight value here is W2. So X1 will be multiplied with W1, X2 will be multiplied with W2, and all the weighted inputs. Now this input has been weighted inputs because we have multiplied it with weight. So this is called weighted input. Now these weighted inputs are added together with a bias. Now what is bias? I'll tell you later. All these terms I'll introduce to you in depth. Okay, so these are weighted inputs and they are multiplied here. Okay, and then they are added and bias is also added. Finally, this sum is passed through an activation function. What is activation function? It is there in your syllabus. It is part of first unit and we will discuss. So sum is passed through an activation function and then output is produced by. So activation function is used here to turn an unbounded input into an output that has a nice predictable form. So that's why we use this activation function. And there are several activation functions available in literature, and we will discuss those activation functions also. But this is how like neural network works. Okay, so these are the different architectures. This is perceptron, this is feed forward, this is radial basis network, this is deep feed network. Now all these networks, you can notice that I have used three colors here in these networks. And these three colors, they represent the different layers. Every neural network consists of three layers. Every neural network consists of three layers. Which are three layers? Input layer, output layer, and hidden layers. So yellow color nodes, they represent input layer. You can see yellow color nodes in input layer. There is always one input layer, not more than one, okay? So there is always one input layer and you can see that every neural network has one input layer. Fine. This input layer consists of some number of neurons, maybe one, maybe two, maybe three, maybe four, right? Some number of neurons are there in input layer. After input layer, we have variable number of hidden layers. Why I said variable number? Because we may have one hidden layer, we may have two hidden layers, we may have three hidden layers. It depends on complexity of these hidden layers, depends on the applications for which we are creating this neural network. Fine. So we may have multiple hidden layers in between. And at the end, we have only one output layer. So you can see that there is only one yellow color layer, which is input layer. There is only one orange color layer, and that is output layer. And in between, we have maybe this green or blue. They are hidden layers, and they may be multiple. Fine. So this is the basic architecture of any neural network. It consists of three types of layers: input layer, hidden layers, and output layer. And each this layer has variable number of neurons. So all circles, they represent neurons. So these are the different architectures. Here you can see. Okay, fine. These are some more. Fine. Now, before we move to the introduction to deep neural network, I would like to take your questions. Like Rutul has some question, and some other students also raised their hands. So Soham, yeah, Soham is also there. Yeah. So please let me know your question. Have you typed your question in chat box? Let me check.
Ma'am, my name is Rutul.
Rutul. Yes, Rutul.
Ma'am, in this diagram, I have seen that it is not any of the example that the final or output layer is the input for the another network. So is it possible that the output layer may be work as input for the another layer?
Another layer means it is last layer, output layer. Output of hidden layer can be input to the next layer. Like for example, for any network, if you see here, see this is input layer. So output of input layer would be output of this first layer would be input to the next layer, which may be first hidden layer. Okay. Output of first hidden layer will be input from the for the second hidden layer, and so on. So once we get output from the output layer, that is what we are expecting from this neural network. So where do you want to feed it? So if you have any idea, or if you have read somewhere that this output which we receive from the output layer, we are feeding it somewhere, please share with me. Then I can discuss more on that. But otherwise, that is the output which we are expecting.
Ma'am, am I audible?
Yeah, you are audible.
Ma'am, I have several questions about this course. First of all, can you suggest about resources and books and websites about what is your
I will
opinion?
surely I will suggest book. Also, I will suggest, but nowadays we refer more online resources. So I will suggest you online resources. I will also provide you some material, some notes which you can refer later. Right. So this is regarding material. Then what other questions you had?
And
Sorry,
ma'am,
uh,
the other questions are that you said the prerequisite is machine learning. So where can we learn that? Because I have not learned machine learning. So where can I learn that?
Okay. Machine learning you have not learned. So the resources which I will provide you, online resources, they also discuss machine learning and deep learning. And they are popular machine learning, or you can also learn about machine learning on any popular platform. MOOC course also you can join. Like you can join any Coursera or NPTEL course if you want to learn in depth. If you want to get overview, then you can like Edureka or Udemy, or you can go to that towards data science, machine learning, machine learning, I forgot its exact name. Then Vidya Analytics. These are like popular resources which you can refer, online resources. If you want to learn basics of machine learning, not in depth. But if you want to learn in depth, then you have to join any MOOC course like Coursera or Leading AI. Yeah, where you can join that NPTEL course if you want to learn in deep. Any other question? Yeah, Kamal. Kamal, if you want to ask. Okay, I cannot hear you. So let us move forward. Okay. So this is about the basics of artificial neural network. Very basic, theory I have covered related to artificial neural network. Now let us move to deep neural network. Right. So how it differs from artificial neural network and how they are useful. Okay. Now, this deep learning, as we discussed, is also known as hierarchical learning or deep structured learning. Deep learning is also known as hierarchical learning or deep structured learning. This is a layered algorithm architecture to analyze data. Okay. Now, these deep neural networks are the neural networks with at least 3 or 4 layers, hidden layers. Now, here you can see that this is input layer, this is output layer, and in between there are 3 hidden layers. So at least 3 to 4. But for some people, like especially non-technical, any neural net qualifies a deep learning, regardless of its depth. And others consider a 10-layer neural net as shallow network and above 100 as deep neural network. Fine. So in deep learning models, data is filtered through a cascade of multiple layers, wherein each successive layer uses the output from the previous one to inform its results. So deep learning models can become more and more accurate as they process more data, because data passes through more number of layers, and as more and more data is exposed to more and more layers, like learning increases, and the accuracy of such deep neural network also increases, especially learning from previous results to refine their ability to make correlations and connections. So these hidden layers, they serve to perform the mathematical translation task that turn raw input into meaningful output. So here I would like to tell you the basic differences between the artificial neural network, which we discussed previously, and this deep neural network. So several types of neural networks are available, and neural networks can be recurrent, or they can be feed forward, or they can be feed forward neural network. They can be feed forward. So the basic difference between artificial neural network and deep neural network is that artificial neural network usually has 1 or 2 hidden layers, while deep neural network has usually 3 or more number of hidden layers. That is the first and basic difference. Fine. Second, there is like no definite answer to these questions that what are the differences, but we can say that artificial neural network is shallow neural network, while deep neural network is deep in architecture. So many people, they suspect that what's the meaning of deep. So sometimes like 10 layers is also considered as shallow. Sometimes 1 layer is considered as shallow. But we also have deep neural networks having as many as 150 hidden layers. So they are really, they are deep in real sense, and so many hidden layers are there. Maybe shallow network would need more neurons than the deep one. Maybe shallow network is more difficult to train with current algorithms, and maybe a shallow architecture does not fit to the kind of problems we are usually trying to solve, like object recognition and object detection. So because of that, these are the limitations of shallow network. I repeat the limitations, that shallow network would need more neurons than the deep one sometimes, depends on application. Shallow network is more difficult to train with current algorithms because it has more nasty local minima or the convergence rate, and they are slower also. Moreover, shallow architecture does not fit to the contemporary problems, like when we want to detect objects, when we want to detect object, and when we want to classify those objects. So there are such limitations, and so we need deep neural networks. Okay, now this deep neural network requires specific input of data, and neural networks needs to learn all the time to solve the task in a more quantified manner, even to use various methods to solve these networks, right? So These are the basic differences between this neural network and deep neural network. The neural network can get one result while the deep neural network solves the problem more globally, and it can draw conclusions or predictions depending on the information supplied to it. Neural network requires a specific input of data and algorithms of solutions, while deep neural network can solve a problem without a significant amount of marked data. So these are on the other hand, deep neural network analyzes and groups creative and analytical components of information to ensure that the object is identified correctly. So these components are not brought to the system directly. This is how the deep neural network works. So basic difference, these are the basic differences between these two. We will see in deep that how deep neural network differs from traditional artificial neural network. These are various applications of deep neural network, or we can say these are also applications of machine learning. Like these are some of the real life sectors where we use machine learning, deep learning. Image recognition. Image recognition, you can think of the applications where image recognition is not required. No, almost in every real life sector. For example, if we consider e-commerce website, image recognition is required. If we consider social media, image recognition is required, right? Like our real life Aadhaar card and all, when we use them, image recognition is required. Image recognition has been like part of several. If you think of any surveillance system, security system, image recognition is required. So image recognition in almost like useful for many real life sectors, and there we use this deep learning algorithms. Natural language processing, portfolio management and prediction of stock price movements, drug discovery and better diagnosis of diseases in healthcare. Not only these two, there are several sectors in healthcare where we use this machine learning and deep learning. Speech recognition, robots and self-driving cars. Everywhere we use this machine learning and deep learning algorithms. Okay, so in healthcare, if I give you more example in healthcare, or if I tell you more about the image recognition, the most popular area of application of deep learning is image recognition. Deep learning aims to recognize and identify people and objects in images, as well as it aims to understand the context and content. Right? You know that when you upload any photo to your Facebook, then it suggests to tag your friends if it identifies your friend's face in your photo. So this is also deep learning based application. Image recognition is already being used in several sectors like gaming, social media, retail, tourism, etc. And this task requires the classification of objects, because when you upload any image, that image may contain several objects. So first, machine needs to identify, detect those objects, and then machine needs to classify those objects. So deep learning is used for detection of objects and classification of objects within a photograph as one of a set of previously known objects. And a more complex variation of this task is called object detection, which involves specifically identifying one or more objects within the scene of the photograph and drawing a box around them. That is object detection. If I talk about the healthcare in detail, then whether it is breast cancer or skin cancer or say colon cancer, mobile, whether it is like a cancer diagnosis, any kind of cancer diagnosis, or it is mobile and monitoring apps, or prediction and personalized medicine on the basis of biobank data, this deep learning is completely reshaping the life science, medicine, and healthcare today. Innovations in deep learning are advancing the future of precision medicine and population health management in unbelievable ways. And this computer-aided detection, computer-aided disease diagnosis, quantitative imaging, decision support tools, and computer-aided detection, they are playing a big role, and they will play a big role in years to come in healthcare sector. If we talk about the self-driving car, full-blown self-driving cars like Google's need to teach a computer how to take over key parts of driving, how to take over the key parts of driving using digital sensor system instead of human senses. And to do that, companies generally train algorithms using large amount of data using deep learning algorithms. You can think of it as how a child learns through constant experiences and replications. So this is how deep learning algorithms learns through constant experiences which are captured in past. So they learn through a large amount of data, and we are improving this. Apart from these applications, these are some of the fields, as I told you. Apart from these applications, the top application areas of deep learning across industries are fraud detection, fraud news detection, fraud transaction detection, chatbots, right? We are using chatbots in several real life sectors. I hope you are noting down these applications, though I'll provide you some notes. Okay, then colorization of black and white images. All past movies, black and white movies, they are available in their color versions are available. They are available in colorized version. So colorization of black and white images has been possible through this deep learning algorithms. Adding sounds to silent movies, right? It's not like a silent movies were there or silent movies are there and we need to add sounds, but movies are made like that. Movies are made like that. The scenes are shooted, and then the sounds are added to those movies, those silent movies, those edits, right? So scenes are captured, then edits are created, and in those edits, the sounds are added through this algorithms. Video summarization, right? There is a big video, and if you want to present a summary of what is there or what contents are there in video, then we use deep learning. So video summarization using deep learning. Automatic game playing, right? You play several online games. So backend, like who is there as opponent? Algorithm. Deep learning algorithm is there as an opponent. So you can play games, and there we use deep learning algorithms. Language translation, so many examples. Today we know that you can search in any language, not in any language, but many languages are supported by Google Translator also. You can search Google Translator translate from English to more than 100 languages. So translation from those languages to English and English to those languages has been possible with the help of deep learning algorithm. And Gujarati is also there included in those languages. So you can translate using Google Translator from English to Gujarati, Gujarati to English. So this translation, not only that, you know that you can search through your voice. Search through voice is also possible. So deep learning algorithms are there. They have learned because accent are different. Accent of different people are different, and that algorithm has learned from different people. The algorithm has learned different accent, and it answers your query when you use speech to for questions. Pixel restoration. I'll not discuss this in detail because it is computer vision application and may not be much clear orally. Mood detection, photo descriptions. Yeah, you can generate photo descriptions. Suppose photo is there. So what deep learning algorithm will do? It will be trained to detect context, to detect objects, right? To classify those objects and to correlate those objects and to create the contents. So content creation through photo or photo description is possible using this deep learning algorithms. Demographic and election predictions, that is also possible using deep learning algorithms. Deep dreaming, there are many more applications if you search in Google of deep learning in different sectors, and deep learning has proven beneficial in almost every real life sector. So this is a brief that how deep learning is useful. Okay. Any questions till this point? I simply introduced artificial neural network today in simple terms, that how it is similar to biological neural network. Terms, analogy between this artificial neural network and biological neural network.
Ma'am,
Then,
I'm
yes.
but Maulik, and my question is,
Yeah.
which architecture is more complex, feed forward or current recurrent neural network? Because in feed forward neural network we have more hidden layers, because we don't consider the previous input of the hidden layer, and in recurrent neural network we consider previous input also.
So we will not say that which one is complex, but usually the deep learning networks are considered comparatively complex than artificial neural network. Now, feed-forward neural network, it is artificial neural network, while this recurrent neural network, it is considered as a deep neural network. Now, you can have you can have simple recurrent neural network also, and it may have as many as 150 neural hidden layers also. So if you create like complex architecture of that recurrent neural network, then you can say that it is complex. If you create more number of hidden layers and complex architecture for feed-forward neural network, you may say that it is more complex. So like in general, we can't say that which is more complex. They both have different architecture, and it depends on application that which kind of architecture you create for that network. But in simple words, like this is feed-forward neural network is artificial neural network, recurrent like a neural network, it is a deep neural network. So in that sense, we can say that RNN recurrent neural network may be comparatively more complex than feed-forward neural network. I hope, Maulik, I answered your question, because it depends on architecture. Completely, the complexity of any neural network completely depends on architecture of that neural network. Yeah, Rutul, if you have any more question. Yeah, let me check if there is any question in
Ma'am.
chat box. No question. Yeah.
Ma'am, I have doubt that in difference between this artificial neural network and deep learning, is there any possibility that deep neural network has a large number of hidden layers or more than 3? So is there any chance of data losses during the transfer from main input to
Rather,
last
it has
output?
advantages. It has advantages when it has the CNN, which we are going to discuss. It has more than 3 hidden layers. It can have. We can have shallow CNN. We can have deep CNN. It depends on our application, which we will discuss when we will discuss CNN. So we have many, like we have ResNet, which has 150 layers, hidden layers. So there are several architectures available which have several hidden layers, and they are deep in real sense. Yeah, I hope I answered your question. Yeah, Pujan.
Good evening, ma'am.
Yeah, good evening, Pujan.
Ma'am, in an article I had learned that under the machine learning, there are three different learnings which are supervised, unsupervised, and reinforcement learning.
Reinforcement learning, right.
So deep learning are under the which these three types of learning.
Same,
Deep
we
learning.
also have same categories here also, supervised, unsupervised, and reinforcement. Same
What, ma'am?
categories we have. We
Okay.
also have same categories here also, supervised, unsupervised, and reinforcement. We also be supervised. And the
Okay, ma'am. Thank you.
advancement learning algorithms is advancement beyond the semi-supervised. We have traditional 3 categories: supervised, supervised, unsupervised, and reinforcement. We have category semi-supervised. That the latest advancement is self-supervised, self-supervision. So the self-supervised algorithms, they were introduced in 2020 by Jan LeCun, who is also inventor of this convolutional neural network. So Jan LeCun, who is a chief AI scientist of Facebook, he invented the self-supervised learning algorithms in 2020. So this is the advancement in learning algorithms. We have all these learning algorithms here also. because these are learning algorithms. So whether it is machine learning or deep learning, we have these categories. Yeah, Paras? Paras?
Hello.
Yeah, Paras.
Hello. Yeah, good evening, ma'am.
Yeah, good evening, Paras.
Hello. Am I audible?
Yeah, you are audible.
Yeah, what was the need to structure the neural network as same as the biological neural network?
Because biological neural network is used to learn and we want machines to learn. I told you that machine learning is used wherever we want automation. So we want to reduce manpower and we want to automate tasks. When we want to automate tasks, we want machines to learn. Now, how machines can learn? Machines can learn from data. So we provide data to machines, and machine learning algorithms, they learn from data. For example, suppose you have a set of label data. I give you a simple example. Suppose you have a set of alphabets. You have a set of English alphabets. You are feeding this alphabets to machine again and again because you want machine to learn that this is alphabet A, this is alphabet B. Okay, now alphabet A, B, C, D, if you may have like different people, they write in different, they have different people have different handwriting, and the curves and you can say like texture of different handwriting is different. So if I want machines to learn alphabet A written by anyone in any style, then I need to feed a huge amount of data to machine. I need to feed A written by in different styles. I need to feed A alphabet written in different styles to machine so that machine can learn that, okay, this is also alphabet A, this is also alphabet A, this is also alphabet A. So if you feed more data, its learning increases. And once it learns, it will be able to detect that alphabet A. So why this machine learning, why this artificial neural network are similar to biological neural network? Because biological neural network is used like it is there in brain, and we all know that brain is incredible organ of human. We learn through our biological neural networks, and we want machines to learn through this artificial neural network. So machine learning algorithms are nothing but statistical algorithms. These algorithms are exposed to data. These machines or machine algorithms, they learn from this data and they be expert. Once they learn, they be expert, right? And then you can automate the task. I hope you got the point that why we need a artificial neural network, because we want machines to learn from the data. You know, this machine learning algorithms, they are not new. They were introduced, and perhaps me, Professor Gopi, Professor Nilesh, we all learned this subject in 2001 as an elective subject when we were studying together. But we never used this subject. In fact, personally, I did not use this subject then after. I started using and applying this knowledge in last 1 decade because we are generating digital data in last 1 decade. आप सोचोगे तो 1 decade से पहले digital data इतनी amount में नहीं था. Now, digitalization has been common in every real life sector, and in every real life sector, we have digital data in massive amount. Now, when we have digital data in massive amount, we can make use of this machine learning algorithms. We can make use of this AI techniques to analyze this data, because this is the main task of AI techniques. This is the main task of machine learning algorithms, that they learn from data, but they learn from digital data. Earlier, we used to record everything in notebooks. आप hospital में जाते थे, notebook में वो note करते थे. But now the digitalization is available in hospitals also. Digitalization is available in banks also, because every record is available in digital format. So when data is available in digital format, we can expose this data, like we can, this data can be fed to machine learning algorithms, and algorithms can learn to make these processes automated. So I hope you got the answer that why we have artificial neural network similar to biological neural network. Is that fine? Did I answer your question? I don't know. Yeah, who is next? Yeah, Rutul, you have more question, then you may ask.
Ma'am, so we can
So
relate that
हाँ,
So we can relate
yeah,
that
yeah.
this deep learning and machine learning has a is highly dependent on data science and data analysis, because
Yeah,
by analyzing
yeah.
the data we
Tell
are
you, very good question, Rutul. I tell you here, very good question. Thank you for this question. I forgot to tell you. Machine learning and data science, they go together. Machine learning cannot exist if there is no data science. Data science subject cannot exist if there is no machine learning. Because in data science is a mixture of three fields. It is a combination of three fields: machine learning techniques, domain knowledge, machine learning techniques, domain knowledge, and data. So this data science, which is a combination of three things, if we have data, but if we don't have machine learning techniques, data is of no use. Because who will analyze that data? Digital data. I'm talking about the digital data, right? So we have massive amount of data in every sector, as I said, in banks, in finance, in agriculture, because agriculture में भी आजकल हम sensor से सारा data continuously sense कर रहे हैं. So when we have a massive amount of data which is continuously sensed by sensors in healthcare or in agriculture or in any other sector, like pollution monitoring के लिए आजकल smart cities में भी हम sensors use कर रहे हैं. So sensor networks are used in many ways and many areas, and they are sensing data continuously. And this data is of not useful if we do not analyze it. So who will analyze? How they will be analyzed? So AI techniques are used to analyze this data. So machine learning is used because we have digital data now, and data science is there because we have machine learning techniques. So machine learning and data science, they go together. We cannot have, because if you have learned data science, let me tell you that there are 5 major steps in data science: data gathering, data cleaning, exploratory data analysis, and modeling the data. Modeling the data means once we clean data and we carry out exploratory data analysis, now we have data, we have refined data. We feed this data in 4th step of data science. We feed this refined data to machine learning, deep learning algorithms, so that algorithms can learn from this data. And then we present this data. Then we use this trained models, trained algorithms to make future predictions or for classification problems, and we use them in real life sector for applications. So this data science, it would have not been possible if we would not have this machine learning, deep learning algorithms. I hope this is clear that they go together. Yeah, any more question? Yeah, Kamal. Yeah, Kamala.
Hello, ma'am.
You can. Yeah, Kamal.
Am I
Yes, I can.
audible?
Yeah.
So, ma'am, in short, can we say that in case of AI, we can't know what is happening in our AI because of neural networks?
I sorry, I didn't get your question.
Like,
What is
ma'am,
happening?
हम ये नहीं जान सकते कि दूसरे लोगों के मन में क्या चल रहा है, उसके दिमाग में क्या चल रहा है, तो वैसे हम AI में भी देख
कर
सकते हैं
सकते हैं,
कि
ऐसे भी रिसर्च चल रहा है। ईजी मशीन से जो रिसर्च चल रहा है, पूरी एक सर्किट बना सकते हो आप, उसकी कैप बना सकते हो, उसको लगा दो, सेंसर से आपके मन में क्या चल रहा है. पीपल आर वर्किंग ऑन दिस, दो वी आर नॉट 100% सक्सेसफुल इन दिस एरिया. रिसर्च इज गोइंग ऑन इन दिस एरिया, बट दैट काइंड ऑफ एप्लीकेशन लाइक रिसर्चर्स आर डेवलपिंग एंड दे आर वर्किंग. Scientists are working on such applications. Behavioral analysis and everything, it is dependent on this. Yeah. Soham, yes.
Ma'am, am I audible?
Yeah.
मैम व्हाट आर योर पर्सनल सजेशंस फॉर बिगिनर्स? मतलब मैं अगर ऐसा पूछूं कि अगर हम मतलब बिगिनर्स ही अभी इस सब्जेक्ट में, तो आपके मतलब ऐसे मतलब क्या आपकी सलाह राय होंगी कि मतलब क्रिटिकल पॉइंट्स होंगे हमारे लिए, तो आप जरा शेयर कर सकते हैं, क्योंकि मतलब ये जो आप
क्रिटिकल
बढ़ा रहे हैं,
पॉइंट मतलब क्रिटिकल पॉइंट्स रिलेटेड टू,
मतलब कि हमें इस सब्जेक्ट के लिए कौन कौन सी चीजों का ध्यान रखना है, मतलब कि आपकी कोई भी मतलब पर्सनल
अच्छा
राय
अच्छा
है
अच्छा
वो।
अच्छा अच्छा, फॉर दिस सब्जेक्ट यू आर आस्किंग फॉर दिस सब्जेक्ट. ओके, फॉर दिस
हाँ
डीप लर्निंग सब्जेक्ट you should have fundamental knowledge of machine learning और टर्मिनोलॉजी रिलेटेड टू मशीन लर्निंग, जैसे आज किसी ने बताया कि सुपरवाइज्ड अनसुपरवाइज्ड लर्निंग होता है, रीइंफोर्समेंट लर्निंग रहता है, राइट? सो यू शुड बी नोइंग दैट कि हाउ मशीन्स लर्न. मशीन लर्निंग के लिए बहुत सारे एल्गोरिदम्स हैं, एंड network is one of them. Like, this is not only the way how machines learn. There are different ways, there are different algorithms via which we can make machines to learn from data. So artificial neural network is one of them, and in this subject we will mainly focus on artificial neural network. Artificial neural network related terminology I will discuss in depth, right? And the terms like bias, activation function, loss function, etc. will be discussed. How artificial neural network works, that I will discuss. Fine. You should have fundamental knowledge of statistical techniques, statistics. You should be knowing the basic statistics, right? We will not, you will not much apply, but sometimes when I'll discuss some functions, you should be knowing the statistics related to machine learning. Fine. So that is also prerequisites, but again, I tell you that not in depth. You should have overview of statistical techniques. जैसे अभी डेटा साइंस तो इसमें नहीं आ रहा है, तो ज्यादा स्टेटिस्टिकल टेक्निक्स का नॉलेज नहीं चाहिए, बट मान लो when I discuss application of this deep learning in real life sector, so it goes from all steps of data science: data collection, data cleaning, exploratory data analysis. So there you to understand that part of application, you should have basic knowledge of statistics. जैसे आपको पता है कि मीडियन, मोड, सब क्या रहता है, स्टैंडर्ड डेविएशन एंड ऑल, तो वो थोड़ा आपको पता होना चाहिए. Other than that, you will be able to, like, computer vision थोड़ा आएगा, but that I will discuss when I will discuss the object detection and object recognition and classification, because this subject mainly focuses on deep learning for computer vision. So you should have preliminary knowledge of computer vision. Even if you don't have, don't worry. I will discuss when I will discuss those concepts, because the CNN which we are going to learn in detail in this subject, this is mainly for images, for computer vision applications. So you should have fundamental knowledge of computer vision too. और जैसे मैंने बताया, if you want to enroll for this courses, you can enroll on Coursera, NPTEL, leadingai.org. You can enroll on these platforms. बाकी तो नॉर्मली आप भी जानते हो कि ट्यूटोरियल्स पॉइंट है, जावा टी पॉइंट है, विद्या एनालिटिक्स है, टुवर्ड्स डेटा साइंस है, एड्यूरेका है, बहुत सारे पॉपुलर सोर्सेस है, यूडेमी है. सो यू कैन ऑल्सो लर्न बेसिक्स फ्रॉम देयर, right? But standard platforms are Coursera, NPTEL, leadingindia.ai. So leadingindia.ai पे भी आप enroll कर सकते हो. Good sources are there, and they have tie-up with Stanford and Coursera too. Leadingindia.ai, they have tie-up. Yeah, Hansi. Hansi. Okay, any more question? Yeah. Deep, yeah. Deep, you have question?
Am I audible, ma'am?
Yeah. आज आपको जितना पूछना है पूछ लीजिए. Next time से हम questions end में लेंगे, लेकिन आज आपको बहुत questions होंगे because we have yet not started this subject. Fine?
Yeah.
So you can ask me.
My question was that in neuron layer, hidden layer, what are the functions that are executed in hidden layer? Does there any kind of pattern evaluation or? Okay.
Hidden layer does mathematical process. So that I will explain you deep. So it's not possible, like briefly मैं बता दूं, but mathematical operations होते हैं वहां पे hidden layer में. पूरा mathematical होता है. Let me tell you in brief. Any neural network, it includes a huge amount of computation. And that's why it is said that when you implement any deep learning based applications, you should have good resources. Good resource in terms of computation power. You need more computation power because these are computationally, they are highly, this deep learning based applications, they involve a huge amount of computation because all these neural networks, they perform mathematical tasks. And all these hidden layers, they also perform mathematical tasks. So complete mathematics is involved in this artificial neural network. But detail we will discuss when we will start this artificial neural network in next class. Yeah, Poojan.
Ma'am, what is the basic definition of computer vision?
Computer vision, it is like associated with artificial intelligence. It differs from this, you can say, image processing. Computer vision, you can say, a field of computer science that focuses on enabling computers to identify and understand objects in images. Objects and people in images and videos. So computer vision, you can say, other types of artificial intelligence, computer vision seeks to perform and automate tasks that replicate human capabilities. So it is associated with AI. Computer vision, a type of artificial intelligence, enables computers to interpret and analyze the visual world, and it enables machines to identify people and objects from the images and videos. Like facial recognition technology, it is computer vision example. Yeah. Yeah. Vihan?
Yes, ma'am. Am I audible?
Yes.
So, ma'am, my question is that you told that deep learning requires a lot of algorithms, which performs in hidden layers. There are many mathematical computations over there. So,
yes,
my question is, ma'am, that if I have a lower spec device which is not able to process those computations, like I am using my phone camera, and it has a face detection deep learning AI thing. So
correct.
is my device supported over there, or will my device not work?
So you mean to say that your device has limited resources?
Yes.
And deep learning requires high computation power. So how whether your device will support those algorithms? Yes, your device will support those algorithms because CNN, it has thousands of parameters. When we train this convolutional neural network, which is deep in architecture, it has thousands of parameters, sometimes in crores. I'll show you in my application that there are how many trainable parameters when we train CNN. It depends on architecture. And if architecture of CNN is deep, it may have trainable parameters in crore. Okay, now this requires a lot of memory and computation power. Okay, and as you said, we also have some devices where we have limited resources, and we cannot, like, those devices cannot afford this high amount of computation. So for such CNN, what we do, we apply optimization techniques. There are CNN optimization techniques, and the job of this optimization technique is, it is another, like, it can be another subject, optimization techniques. So there are CNN optimization techniques which reduces the number of trainable parameters, and sometimes, like, they're lesser than half. Like if there are 1 crore parameters, trainable parameters, and if you apply optimization techniques, it reduces this number of trainable parameters, and that way it helps us to reduce the computation power. This is one way. Okay. Second way is we also have a special tools to implement applications on such devices. For example, later I'll tell you that using which Python libraries you can use CNN. So one of the Python libraries is TensorFlow, and upon this TensorFlow, Keras is built. Now both this TensorFlow and Keras, they support a different version to implement these algorithms for they support algorithms to implement applications for devices which have limited resources. So we have several ways when we have limited resources to implement these algorithms, and we can deploy those ways. And the main way is apply optimization algorithms. Applying these algorithms, not only parameters are reduced, but we also eliminate some of the layers from the CNN if they are found not useful, if they are found to capture the same features which other layers are capturing, and so on. So there are several ways to reduce the computation power of these algorithms. Okay, any more question? Yeah, Kineta. Yeah, Kineta.
So, ma'am, it is like that CNN is more useful than ANN and DNN.
ANN is a basic version. It is mainly used for machine learning, artificial neural network. When you want to build machine learning applications, we use artificial neural network. Deep neural networks are extension of artificial neural network because they are deep in architecture. Their architecture is similar to artificial neural network, but they are deep in architecture because we have more hidden layers. And these deep neural networks, we have different types of deep neural networks, and they are mainly categorized in two categories: deep neural networks for computer vision and deep neural networks for natural language processing. For example, RNN, somebody asked me something related to RNN. So RNN, LSTM, these are mainly used for natural language processing, while this CNN is mainly used for computer vision applications. Now, we have so many extensions of CNN. I told you that we will also discuss, there is one unit in your syllabus, which is transfer learning based CNN. Okay, so there you will learn that every year one or more than one transfer learning based CNN architecture is proposed. So these are extension of CNN. Not only that, the advanced architectures of CNN are UNIT, transfer learning based UNIT. Then we also have Deep Lab V3, Google's Deep Lab V3. It was proposed in 2020 or 2021. So many architectures are there which are extensions of the CNN. CNN is based in computer vision. CNN was mainly introduced for computer vision applications, and this was introduced by Jan LeCun only. So, but after CNN, like many extensions have been proposed, many modifications have been proposed, and they have been proven more beneficial than basic CNN in computer vision. So CNN is mainly for computer vision. Fine. Any other question? Yeah, if no more questions, then we can depart today, and I will start exactly as per syllabus from next class. Yeah, Dhruv, you have question?
Hello, ma'am. Good evening.
Yeah, good evening, Dhruv.
हाँ मैम, as you said कि डीप लर्निंग सीखने के लिए वो मशीन लर्निंग के टर्म्स है.
Dhruv, your voice is breaking. I'm sorry. Yeah, Dhruv.
Hello.
Yeah, Dhruv.
Ma'am, as you said, to learn deep learning, we have to understand some machine.
Basic concepts of machine learning, right?
Hello.
Yeah, Dhruv, I can hear you, but you can also type your query in chat box if you feel ki my voice or your voice is breaking.
Hello.
Yeah, Dhruv, I can hear you.
Ma'am, what is other that required to learn deep learning?
That we already discussed, right? That is where you need to go through fundamentals of machine learning, some basics of statistics. And as we will be learning CNN, like basics of computer vision. But it's not mandatory. I will discuss like whenever those topics will be covered. Yeah, fine. Any more question? Yeah, so if no more question, then let us depart today. Fine.
Okay, ma'am. Yes.
Anyone? Yeah.
Yes, there is no question from student side.
Yeah. Fine. So now we will meet on Thursday from 6 to 7 and we will go exactly as per syllabus. Meanwhile, you can learn basics of machine learnings if you wish. Otherwise, I will, like, whenever comes any topic, I'll discuss during the discussion, right? And have a very good evening now. Fine.
Thank you, ma'am.
Thank you. Thank you, everyone. Yeah, may I leave?
Yes, ma'am, you can leave.
Yeah. Thank you.
Yes, dear all the students, you can leave.